Okay, so I have problem 4 pulled up. I figure I may as well do this one because the other ones we did in class, and I just don't want to do something we haven't done in class because that might count as cheating. So the first two sections of this problem are easy enough. You have the address class, which is given away by the first section of the network address, where it says 210 right here. So if you open the first subnetting workbook, under the IP address classes, you see class C has a range of values between 192 and 223. So you know it's class C, in which case the first three sections refer to the network section of the address, and the last section refers to the host section of the address. So that answers the first section. And with the default subnet mask, when the default subnet mask refers to, which parts of the network address refers to the network itself. And since it's class C, all of the bits in the first three sections are turned on. So it's 255, 255, 255, 0. Reason why it's 255 is because this number right here is 255. 255 is the highest number you can represent in binary in 8 digits. So we did that part too, and that should be there as well. So if you didn't get why I got that, just go through the first two subnetting workbooks. That will, show why that's the answer there. But to answer the other parts of the question, you would borrow bits from the first section of the network address, and you would fill that into the host section of the network address. You could always borrow bits from the left-hand side, but you can never borrow them from the right-hand side. So the left-hand side will remain constant. That part's not changing. I put a line here to demarcate which part is the network and which part is the host. So we can always borrow from the left, but we can never borrow from the right. Well, how many to borrow then? Well, I wrote these formulas at the bottom that will say, okay, the number of subnets is a function of 2 to however many ones you've borrowed. And it tells you that you need 6 subnets, in which case, if you borrow only 1 bit, now we're borrowing bits, but it's not like any bits on this side are going away. When we say borrow, we can't borrow more than however many ones we have as part of the address class. That's the max number of bits we can borrow. So, but if we borrow 1 bit, well, 2 to the first power is only 2. That's not enough. We need 6 subnets. If we borrow 2, well, 2 to the second power is 4. That's still not enough. If we borrow a third bit, then that's enough. That 2 to the third power is 8. 8 is more than 6. In which case, we borrowed 3 bits. And the number of subnets is 8. Since 2 to the third power is 8. And with this part of the address, you just fill in the rest of the address with zeros. It's correct, I just need to make it longer. And such that we have the same number of bits. Well, not necessarily the ones that are turned on, but just so that you have the same number of ones and zeros above what you had in the default subnet mask as what you have in this custom one you're creating now. So you would then know, okay, how many host addresses would I need? Well, you just count the number of zeros you filled in. You have filled in 5 zeros. 2 to the 5th power is 32. And they tell you need 30 usable hosts. Well, the number of usable hosts will always be 2 fewer than the total number you have. So 32 minus 2 is 30. And we needed 30. We have exactly 30, so it worked out perfectly. And in order to create the custom subnet mask, you just read whatever you just created in binary right here. So it's 255, 255, 255, and you have this section right here in binary. That is 224 in binary, since 128 plus 64 plus 34 is 2, plus 32 is 224. And okay, well, if we had an address class B instead, we would still have 8, and then the demarcation between the network and the host will be in the middle. I want to view that. I can't count. So we had class B, and we needed to only borrow 3 bits. We would fill in everything with 0. Just so, I mean, that's not applying with problem 4, but for the future problems, you would just have a lot of zeros there. So that's how you solve the problem, really. It's not that hard. It's just a matter of being able to apply these algorithms to generate the answers here.